So let's put this all together. So for our binomial models, and this works for Bernoulli trials. So to know that you're going to be using this method of calculation, again, there should only be two outcomes, success versus failure. The trial should be independent. In that our probability of success shouldn't be changing. That kind of matches up with independence. And something else that comes through with these binomial models is there's a set number of trials. So in the case of the basketball player, they're always telling us how many free throws she's going for. So there's a set number of times she's going to throw the ball, and then from there we look at these different probabilities of values occurring. So there's going to be a set number of trials. So we talked about P as our probability of success. Q, which is just the opposite of our probability of success, is our probability of failure. Then what we're doing, and some new notation for us, we're going to use this capital X to represent our variable. It's what we're going to find the probability of. So X can represent these number of successes out of n trials. And what we want to do is define a model for our value of X. And that's what's coming through right here. This notation, the probability model for this variable X. So the notation here, we have our variable X, this kind of squiggle symbol in between them. How we read that is defined by. So based on the context of our question, what we'll see is we know it's binomial model, so X, our variable, is defined by, and then we write out the word binomial. And in terms of how binomial models work, we need two pieces of information. We need the number of trials, which is n, and we need the probability of success. If we have all of that information, there's only a certain certain ways that this whole model can behave for all possible values of X. So, finding our probability of success in n trials, this is where we can see our two pieces. Here is our combinations part. So we have n trials. How many ways can we have X successes? So there's our combination part. Then you take your probability of success and raise it to the number of successes that you want to see. And then when you take your probability of failure, you take your number of trials and just take out the number of successes that we had. So if we go back to what we did with the basketball player, kind of see, given this scenario, how would we apply this directly? What it would look like is we're looking for this probability of one success out of 4 trials. We'd have 4 trials, and how many ways can we have one success? Times, then we take our probability of success, and as we've been saying, out loud at least, we want one success, so because we're looking for this probability of one success, that's going to give the exponent of 1 on our probability of success. And then for our probability of failure, 3 coming through, what made that happen is the idea that, well, she's going to shoot the ball 4 times, so there's these 4 trials, but 1 is going to be a success, so we need to take that out of there. We're just going to leave over 3 total failures there. So that's how this whole formula would be. In terms of the rest of our calculation, just use Excel or some form of technology to calculate that value, and then the rest can just go into the calculator and we can get a value out for that. Here is the formula for calculating the combinations, but like I said, feel free to use technology instead. We have this calculation for expected value. which would be the idea of, for a certain number of trials, how many successes do we expect? So like for the 4 shots that she's throwing, if we were sticking with 4 trials and we applied this 82% chance of success, we'd get out a 3.28. Means out of the 4 shots, we expect her to make 3.28 of those free throws. What we can also do is get a standard deviation out by taking the square root, and you take your number of trials times the probability of success times the probability of failure. And that would tell us, let's see if I just carry out this multiplication here. So this gives us a 0.7684. So how we work with these two numbers is like how we described mean and standard deviation before, in that we expect this to occur, and on average it deviates by this much. So how I would put this into a sentence would to be, say, out of 4 free throws, we expect her to make 3.28 of them, but on average that deviates by 0.7684 free throws. So these are some key formulas that we need to know when calculating binomials when we have the scenario of only 2 possible outcomes, independent trials, and then the set number of trials. So what we're going to do down here is practice using the formula for different scenarios. So our free thrower is still making that 82% of her baskets, so there's our probability of success, which means our probability of failure is still that 0.18. Assume each shot is independent, so we're good there. And then we get our set number of trials. So she's going to shoot the ball 10 times. So for this, if we wanted to define our binomial model, in that without even looking at what's going to be calculated below there, we have this variable of x. And x is going to represent the number of free throws made out of 10 attempts. This is the idea of our number of successes out of n trials. For us, it's this number of free throws that she makes out of the 10 tries. And this variable x, how these successes behave, it's going to be binomial, since we have all of, and then how it's defined with the number of trials. We have 10 trials, and then our probability of success is a 0.82. So if ever you're asked to define the model, this is what we're looking for. We're looking for what is our variable, and then how is it defined? How does it distribute? So, what's the probability that she makes exactly 5 free throws? So for this, we're looking for the probability of 5 sixes. It's like 5 successes out of 10 free throws. So our calculation would go, we have these 10 trials, and for our combination, we want to see how many ways can we have 5 successes. And then what I always do is I just write down probability of success, probability of failure, but we need to figure out the exponents. So what I always think, if this is our probability of success, whatever's part of the combination, that's going to be your exponent there, because we're looking for 5 successes, and this, by having an exponent of 5, is giving us our 5 successes there. And then for our probability of failure, you end up subtracting between those two, so a 10 minus 5. So instead of using formula for this, if you go to Excel and plug in that equals combin 10 comma 5, it'll give you a 252. And then that's being multiplied by 0.82 to the 5th power, multiplied by 0.18 also to the 5th power, which is going to be a 0.0177. So there is a 1.77% chance she makes exactly 5 of 10 free throws. So that's how we find the probability of an exact scenario for a specific value. What's the probability that she makes 9 or 10? So with this, we're looking for the probability of x being 9 or x being 10. And remember with or, we get the addition rule coming through, and there were the two scenarios, disjoint or non-disjoint. With the binomial model, it's going to be disjoint. The idea being that she can either make 9 or make 10. She can't really make both. She can't make not exactly 9 and exactly 10 at the same time. It has to be one or the other. So this is kind of our simple addition rule, where you just take the probability of the one scenario, add on the probability of the other scenario. So with this one, for a probability of x being exact 9, this is where we have 10 trials and we want to see how many ways can we have 9 successes. So if we take our probability of success, we're going to see that 9 times. Take our probability of failure, and you'll have 10 minus 9, that's 1 failure. And then what we're going to do is add on this probability of exactly 10. So we'll have this 10 choose 10. We'll have our probability of success 10 times, and then we're not going to have any failures with this scenario. So that leaves us with the 0 there, coming from 10 minus 10. We plug all of this into Excel, which with Excel you can type in, like if we typed in equals combin 10 comma 9, you can just keep calculating, then do like times 0.82 to the 9. You plug all of this into Excel in one go. I'm going to upload a separate video working with Excel, and I'll be sure to example with these for how you can have Excel calculate the whole thing for you. But if you calculate this, you should get out a 0.4392. So there is a 43.92% chance she makes 9 or 10 of the 10 free throws. With this next one, probability that she makes 2 or fewer, something we're going to see start coming through with these probabilities are inequalities. So the idea of 2 or fewer is that it can be equal to 2 or anything less than 2. So 2 or 1 or 0. This is going to be the case of x being less than or equal to 2, which would be the same thing as the probability of x being 2, or the probability of x being 1, or the probability of x being 0. So we're going to have these 3 scenarios that we're adding together. This first scenario, we'd have 10 choose 2, and then take our probability of success, and we want to see that 2 times, which means if there's 8 trials, if we have 2 successes, then we have to have 8 failures. And then we do the same thing for 1 success, so out of 10 tries, 1 success. So we take our probability of success and see that 1 time, which means our probability of failure we'd see 9 times. And in this scenario where we have no successes, we take our probability of success, and that would happen none of the time, which means we see failure 10 times in a row. If we, it's going to give you a very small number. It should end up being point, and then we're going to have 4 zeros and 3 5. If we follow our rounding rule that we want to use in this course of to 4 decimal places, really this just rounds to 0. But whenever we round to 0, just be careful when you turn it into a sentence, because we don't want to say there's a 0% chance that she makes 2 or fewer free throws. Because if we say there's a 0% chance, it sounds like it's impossible, which it isn't. It's just very, very, very unlikely. So just be sure when you make the sentence with these, we would say there is, and then just throw in close to 0% chance. Or there is approximately 0%. Something to say we're rounding to that value. So there's close to 0% chance she makes 2 or fewer of the 10 free throws. And then for this last one, what's the expected number of baskets? So this is our expected value, which we take the number of trials, which is 10, times our probability of success. So that's going to give us an 8.2. And then standard deviation, you take the square root of number of trials times probability of success times probability of failure, and that's going to be a 1.21. So putting this into a sentence, what we'd want to say is we expect her to make 8.2 of the 10 free throws. And on average, that deviates by 1.21 free throws. So we get our expected value and then how we expect that to change.